Alrighty. So now we're live. Let's do this thing where we just go to this list. I think the first time we should probably look at is Steve's. That's the right one, right?
Yes. Okay, I guess I can start here. Now, Ryan Nowak's not here, but we did kind of work together on this, and James also was involved with some of the discussions here. And this is kind of what we came up with. It's basically we need support for changing the way a property name on a POCO object is handled. So we're proposing four things here: an attribute that you can specify an explicit name, just say, hey, here's the name of the property. No other post-processing occurs on that, and that's the attribute. And then two properties on the options class, the serializer. And then along with that, then, because one of the properties returns a class, and we provide a base class for that with a property, a static property, to get the default camel casing policy. We're not providing any other policies like snake casing, etc., out of the box, but the idea is that someone else can bring their own. Does that make sense?
It does.
What's the camel casing policy? Just whether it's camel cased or Pascal cased?
Yeah, but by default, property names on a POCO object are typically Pascal cased, and in a lot of cases, the underlying JSON is camel cased. Starts with a lowercase letter. So basically, it's very common that the JSON then we have to be able to convert the JSON property names. We have to be able to match those up with the POCO object, which is Pascal cased, and that policy allows you to do that. And then case insensitivity is another thing related to the property name, and that's kind of independent of the name, because you can camel case or whatever or not, and still want your property name to be case insensitive when you're deserializing. Maybe just scroll down to the example section.
Yeah, let me just quickly get my mouse. It's not that easy with two screens. Yeah, I would just wrote a few questions that I had, but
I'll just let you read this. I mean, it's pretty self-explanatory.
So with the camel casing policy, is it the case that this would seem to apply to everything? Like, every property would end up with this same policy. Is that okay? That's
right.
Okay.
Right. Yeah, that was. This is what we started with. Originally, we had a way to specify it on a per type and even a per property level, but for preview 5, this is what we came up with.
I mean, we do have a way to specify it on a property level by, I guess, just using JSON name, right? You just have to do it yourself.
Yep. So, yes. And then with the JSON or with the JSON name attribute, you can have any policy you want, right? I mean, you just have to put it on your property.
And I assume that overrides whatever policy you set. Like, the policy doesn't apply to whatever string you put in there.
Yes, exactly. So if you put JSON name, that's exactly what it's going to be, irregardless of any kind of global setting.
Yeah, so that's basically the question. So JSON name is not subjected to the policy, right? So you never get called for this guy. So as soon as you put JSON name, you basically override whatever policy you set.
Yes.
Is case insensitive preferred over ignore case? Looks like we have a mix of both across the framework, depending on whether you're working with like string or a collection or regex or etc.
So ask again, like I didn't
like is case insensitive versus ignore case preferred?
Oh, you mean the...
Yeah, so like should we name it property name case insensitive or property name ignore case? We seem to have a mix of both usages across the framework depending on what you're dealing with.
Do we actually have case insensitive used anywhere?
Yeah, we've got about 20 to 30 usages of each,
okay.
depending on where you're looking.
Yeah,
in either case, the default to be false. I'm open to naming, but
like for ordinal, we of course use ignore case, and then we've got standalone ignore case in a few places like link and XML and regex, but then we also have case insensitive in some places like collections. Looks to be mostly in collections.
Yeah, it looks like also it looks like it's mostly in the legacy stuff, right? So it's system collections, it's regex, which is also non-generic. So every time we talk about ignore case, it seems to come from the either the string ones or the what was the other one? No, it's just in strings.
There was also one hit in regex. So regex looks to use both.
Oh, great. Yeah, I think either one works for me.
Yeah.
I mean, insensitive kind of, I don't know.
It's insensitive.
Makes more sense to me than ignore case, but maybe it's just me.
Does it make a difference from the Unicode perspective? No.
So
yeah, we are with that normalizing the JSON name coming in to in culture.
Maybe ignore case makes sense since we'll be using it in the context of string comparisons most often.
Can you repeat the last sentence you said, Steve? I didn't catch that.
The way that it's actually done internally is that we take the JSON name coming in on a deserialize, and we normalize it. Meaning, in this case, we convert it to uppercase, but I suppose you could do lowercase using the invariant culture, and then we compare it against our internal cache of the property names, which were also normalized the same way.
Okay.
What does JSON.NET do, by the way?
They have a strategy kind of class, or your a class you basically derive from and manage this yourself.
I see. So he doesn't have pre-canned one for those then?
No, it does. It's just not like this here up front.
I see.
You have to kind of go through more hoops to do this. And okay, so unless I hear otherwise, I'm just going to keep the name.
Yeah, I think that seems reasonable to me.
I mean, people will know what it means.
Yeah.
It's not undiscoverable.
And then this extensibility model here, the idea is that, we're going to provide the camel case one because that's by far the most common. If people want their own snake casing or whatever policy they might have, they can write their own and derive from this class.
So how would So let's say I like the camel casing policy and I want to just tweak some of my names because they're like crappy, right? Like XML or I don't know, some other abbreviations that I want to tweak. Can I extend the camel casing one, or do I have to implement this again myself?
Currently, you'd have to, copy the code, I guess, because that actual implementation is internal.
Yeah. And then the only thing you could do is just use the static one yourself, right? Then the first time you say, camel case name, you just say, I don't know, wherever the static API is, and then you just convert it again yourself, right?
Would you actually have to could you just call JSON name policy .ignore case .convert name?
Yeah, that's what I meant. You
it,
just call the step
good,
yourself, right?
you can forward the call if you want.
Yeah. So, but you do intend people to be able to inherit from this, right? So you would need a protected constructor on JSON name policy. I mean, if you write the code like this in C#, that means the compiler will emit the protected one. But in API reviews, if this is the metadata, that would mean that you don't have a constructor, so nobody could inherit from this. You want?
Oh, at that. Okay.
So that, yeah, just so you know. You probably intend to have a protected constructor, would be my guess. And then my other question is, should we have one that doesn't return a string, but basically does it inside a span, or do we not care?
How does the implementation handle the code gen around this? Is this called like once per type and cached?
Yeah, it's kind of during the warm-up phase, loop through all of the properties and detect this global setting, and then cache it, and then the JSON incoming. And so there's no perf hit. Honestly, there's no perf hit once it gets warmed up because the incoming JSON is expected to match exactly.
Yeah. Yeah.
And then for serialization, we take, of course, the camel case name and output that, right?
I might change my mind on the name property, by the way, because you're not performing a comparison, you're performing a normalization before a comparison, which actually does matter.
So which policy are you talking about, or which name are you talking about?
So you'll want to convey the idea that you're not doing a case-insensitive comparison of the data coming across the wire against a property name on the type. The idea that you want to convey is you normalize both names, and then you do an ordinal comparison of both names against that actually does matter. The reason that it matters is the Turkish
invariant culture.
Sorry, what was that?
Even though I'm using the invariant culture, why would it matter?
So if you have a lowercase dotless Turkish I and compare it against a regular capital I, that will pass as true for ordinal ignore case comparison. But if you have a lowercase dotless Turkish I and you call to upper invariant on it, it will return back the original lowercase dotless Turkish I, which no longer compares as equal to a capital I. Like there actually is a difference between normalization and ordinal ignore case comparison.
Okay, I do mention something along normalization in the performance comment I have. But yeah, I will change the case insensitive, then say something along the values.
We should just change that to like normalized.
Oh, okay, wait, no. You're referring just to the camel case, and then okay.
Yeah. Well, I'm referring to anything that conveys the idea of comparison.
Okay.
So, like from implementation standpoint, like, is it then okay that we actually normalize them rather than just comparing them on the fly?
Personally, I don't think so. But if so here's the thing, right? We need to generate something.
Right.
Like when we're sending stuff out on the wire, we actually have to generate something.
Right.
At that point, that's normalization because you don't have anything else to compare your data to. Right.
You mean normalizing from the properties as they're written in metadata? We have to apply some sort of policy.
So I'm distinguishing between these two operations. When you have a comparison, you have two strings as inputs, and you return a Boolean as your output.
Right.
When you have normalization, it's string in, string out.
Right.
When you're serializing, you have to normalize, right? It's string in, string out. When you're deserializing, it's a bit wonky.
But I think, Steve, correct me if I'm wrong, but my understanding is that this property name case insensitive is not for describing this. It's for describing when you deserialize how you match the thing in the JSON payload to the property definitions on the type. So that would be not normalization then, that would be just matching.
But because of performance, I think that it does make sense to normalize that. Otherwise, because basically the way that the properties are cached in a special type of dictionary, I think that otherwise we'd have to loop have a real dictionary or some other kind of mechanism. But I think if Turkey is the only case, we might.
You have a concept of a leftover property bag, correct? When you're deserializing.
Currently we don't, but yes, we plan on having that.
What would the string comparer be on that property bag?
Well, whatever you said here.
Invariant culture ignore case?
Hopefully ordinal.
If it's ordinal ignore case, then this behavior is incorrect. Because now you have now someone can send you data which won't bind to a property, but where you look up that exact property name inside the leftover data dictionary, it will return that.
I see. So okay, so that basically means we should be consistent in the way we describe this, right?
Yeah.
I still don't understand why normalization is more efficient though, because to me, like you basically read the payload, you take the string that's in the payload, and you look up a property somehow in your cached things. To me, that's a dictionary lookup, and you have to agree on what the comparer is you're using. Yeah. So no matter, like, either we say, if you set this to true, we're using ordinal. If you set this to false, sorry, if you set this to true, we're saying ordinal ignore case, and we set it to false, it means ordinal. Then that would make sense to me.
Yeah.
Because of the way the hash table is structured, it does byte-wise comparisons once after the normalization occurs. That's why. I mean, if we don't want to do byte-wise comparisons for the key, that's just a perfit, and I have to say, okay, if property name is insensitive, then take this other slower path. Otherwise, do the fast path. It's going to be slower no matter what, because we have to normalize it, however.
Yeah, that might be the best thing to do right now, honestly, just so that we don't paint ourselves into a corner.
When you say this, what do you refer to?
This where we don't have a backend store of normalized names, where we compute stuff on the fly.
Yeah.
I don't really want to sidetrack this on implementation details. I'm just trying to figure out if this actually affects the API's purpose at all.
Yeah, I mean, it's behavior, right? I think that the API has to reflect that behavior, and I think we need to agree on what the behavior is that we think is the right one.
Yeah.
So in that sense, I don't think it's sidetracking.
I know early on, some of the goals, of course, were high performance for the serializer over functionality.
Yeah, but you don't want to surprise people, though. That's the thing.
We don't want to do the wrong thing. So if this is, a very rare thing to do, and it's going to surprise people, then fine, we should probably change it. And like I said, it already has a performance concern. But now, if you have a lot of properties on your Poco class, basically we have to fall back to a different algorithm, a much slower algorithm, dictionary basically, or looping through.
I think we can actually solve that under the covers without affecting the API here. I have high confidence we can do that, because property names are almost always going to be ASCII, so we can special case that.
Yeah, we'll agree with that.
Yeah, we can do that. Okay.
So would the name then change, or would the name stay the same?
Let's leave the name for now then.
Okay.
I'll sync with you then, Levi, afterwards.
Yeah.
Just a minute.
Okay.
I know what we were referring to.
It just means convert name can really only be used for generating payloads. It can't ever be used for deserializing, because it will return potentially the.
Which is what I would generally expect anyways, because otherwise you create a fuck ton of strings in your decoding.
No, what I mean is you can't call convert name, cache them, and then say we expect only these exact things to be inbound when we're deserializing. That would be incorrect behavior. It just means we would need, for the convert name for that convert name method, we would want to say this method is only intended to be used during deserialization. You shouldn't call this and cache the results in order to speed up deserialization, because you will potentially deserialize the wrong data, or you'll potentially perform incorrect deserialization.
Meaning you're not matching something when you should have.
Yes.
Okay, well, I mean, we can talk about the implementation later, but
Yeah.
I mean, my assumption is that we can cache the result from convert name.
Well, for generation, for sure. Right?
Yeah,
Like
I don't think for matching on the inbound we can do that. I think there are subtle pitfalls there. But again, okay, that doesn't affect the API. So okay, sure, we should move on then.
Well, I still don't understand. Like, if you say case insensitive true, you can't do an exact match anyways, right? So how do you compare them then? You store both the lowercase and all uppercase?
It's you convert them with gusto. There are ways to do it. It's just non-trivial.
I see.
The default value is false, and we're going to look identically at the bus basically coming in if the default.
Yeah. Okay.
Yeah, my naive assumption is you just have a compare somewhere, and that's what you use to index into your dictionary.
Yeah, compares can't be used to generate data. Compares can only be used to read data.
Well, that's what I'm saying. I think I would assume that, as you said earlier, the convert name is only done once on startup to effectively pre-compute what the output name needs to be.
Yeah.
And then you store this in some sort of property descriptor that you cache based on property info, whatever.
Yep.
And when you look up data from the payload using this property, you either choose ordinal or ordinal ignore case to look up your data, and then that's how you match. That would be my naive view of the world.
That is, I believe, correct behavior.
That is what?
Yeah. It's all different.
He just said he thinks that's correct behavior.
I need to think about that more, but I believe that's correct.
Okay.
The thing is, they're fundamentally different operations. Like, they are truly fundamentally different operations.
Yeah, I think
that's why it's difficult to reconcile this in my mind. And we do paper over that in the framework, unfortunately.
Casing and camel casing, you mean, are truly fundamentally different?
Generating an output string and comparing two strings for equality. Like, normalizing a string and comparing two strings for equality are just fundamentally different. Like, they are completely different things. And we do tend to paper over that in the framework.
Yeah. Basically, logically, if you say, compare these two strings and before in comparison that is case insensitive is different from saying, let me convert both strings for casing to upper or to lower and then compare the results for byte equality.
Correct.
They're not resulting in the same output.
For various reasons. Okay.
All right, so then I think my only other question was earlier, like, should this be span-based? But given that we cache them, it seems like, the payload sizes, the types are finite, so no matter how many requests you get per second, you can pre-cache them if you really wanted to.
The only way that might be a problem is if we do in the future have a concept of just a regular property bag that we want to be able to send out over the wire, would all of those have to go through this as well? Does that mean we need a span overload?
Yeah, I would
think we need to worry about that right now.
No, I think the property bag would only be the residue from what you got. I don't think we would support a property bag for output.
Well, what about if you're serializing a dictionary?
No, we do plan on having an attribute you can put on a property that contains essentially a dictionary. We will put the overflow in there during deserialization and then serialize that.
Does this policy also apply to keys of a dictionary if you're serializing it?
There is a dictionary key policy property here. It's the last one. So we did separate a property name on a POCO versus a property name, a key name in a dictionary. Because you might not want to have both enabled. I don't think you'll do snake casing in one and camel in the other, but you might want your dictionary to be camel cased.
Yep.
So that might result in a very large number.
Regarding naming, should JSON name policy, convert name, etc. all be JSON property name policy, convert property name policy? And similarly with the attribute, instead of being JSON name, be JSON property name.
Since it's using dictionary keys as well,
Yeah.
it's not necessarily a property key. It could just be called JSON. Well, I mean, string converter policy, or I don't know. I mean, but
I mean, in the resulting JSON is always a property, though, right? No matter how you got there, whether it's a .NET property or a .NET key, right? It's still a property in JSON.
Right.
That's true, yeah.
But I mean, honestly, my caliber is low. I think JSON name as an attribute makes a little bit more sense when you put it on the property because it reads nicer. But yeah, either one works for me. So also depends more like how strong you feel here.
I think generally the small name is not descriptive enough, and so I think it should be property name. Primarily because I don't want things to get confused with JSON string or anything else to relate to that, because there's a concept of name generally in JSON, right? It's property name. So what does name even mean?
Yeah, I know it originally came from because of the attribute was called JSON name. So, I mean, we could definitely call the policy JSON property name policy. That works.
And maybe it should be JSON naming policy instead of JSON name.
Works for me as well.
JSON property naming policy works. But then we should probably look at property JSON or property name case insensitive. Is that casing? You know, well, I'm not going to revisit that. I guess, but I think that's fine. Okay, if there's not any more comments on it, I did have a couple of quick questions for feedback on behavior, other than what I need to discuss with Levi afterwards about normalizing. Right now, I mean, I know this isn't really designed, but what's the general thinking? Like, if one of these policies would return a null or an empty string, should we just ignore that, or does it make sense to throw?
You mean if a convert name returns null?
Yes. If somebody writes a bad policy,
Just
basically.
We like within the framework, we generally don't care about our dependencies returning bad data to us. Generally, we just null ref or something like that.
Really?
Yeah, generally speaking. Like if we call a virtual method on our own type, for instance, because maybe someone subclassed us, like we generally don't defend against the virtual method returning null. Like we generally just keep marching forward. Also, if this is hooked up with nullable, and well, it doesn't return a nullable string.
Yeah, empty string would be problematic because you wouldn't null ref, you just produce an incorrect payload.
Oh, you produce the payload they told you to produce. See, an empty string is a perfectly valid key value.
Is it?
Yeah, absolutely.
JSON is weird.
Why wouldn't it be?
Yeah, this goes back to common sense, but yeah.
My intuition would be we check for null and throw. If for no other reason, then it would help someone diagnose where they have a bug.
Sure.
And it doesn't seem like it's on a sensitive path.
No.
Yeah,
so it's like one check and a throwing of a, we must have some JSON serialization exception or something, and just use a string that says, hey, idiot, don't return null.
Yeah, we should probably also do the same thing for empty string, unless we really feel strongly that we should support that. But normalizing a property name to an empty string seems like a bad idea.
And then to Levi's point, when we add the nullability annotations, it'll be a non-nullable string return type, so someone will get compiler warnings if they try and return null most of the time.
Right.
Yeah.
I think though, to the argument of like, should we guard against this? So if you think about the most common use case here, which is, oh, I mean, I'm generally happy with Pascal case or Camel case, but I don't know, my SDK that I use for Azure has some weird, wacky names that need to normalize. So for the most part, I just forward to the existing policy, and then a few things I do my own coding, and I fuck that up. So that now means normal testing will probably find that your payloads are mostly correct, except for the one case where you had the special case where your code now returns invalid data, which might actually be hard to find because it's somewhere deep in the bowels of your, framework, effectively. So I don't like, if it's not perf critical, I think honestly guarding is probably a better idea. And we should probably throw invalid operation or something like this, or I don't know what else you would throw. Not really an argument.
You mean for the empty string case?
Yeah, empty and null in both cases is like, I mean, it's not an argument, right? You're checking an output value, but
back to you can't really have an empty property name in a POCO object, but I mean it would be valid JSON, so you could put it in a property bag or something like that. And then the converter, we could special case empty string out before we call the converter to assume there's no conversion, but someone might want to say, hey, I want to convert an empty string into something else. Who knows? So I'm inclined just to leave empty string alone and then throw on null.
Web for JSON empty key finds a lot of people complaining about frameworks that blocked it, so we shouldn't block it.
Yeah, it is legitimate to have an empty key.
The only thing I would say is like I think the way you would do this is you would just put a JSON name attribute on the property you want to be the empty string. Like I don't think it's a very likely scenario that you want to be able to take a non-empty property, convert it to empty, or take an empty one and make it non-empty, right? So I think in the context of convert, it seems like the wrong thing to do.
They're sort of orthogonal because the attribute implies that you own the type and can change it, and the name applies to anything that you walk through the serializer. The policy is anything that you can walk through the serializer. So if you wanted to replace everything named GUID with empty, then there's no way to do that without letting this let empty go through.
I guess that's fair. I'd take that.
So runtime versus design time, and we shouldn't have different filters. But null doesn't make any sense.
Yeah, I'll definitely throw null then. Okay, my other question, somewhat related in the sense of behavior, I guess, is that if you have case insensitive or you have camel casing, and it's now possible that you have the same property, the same JSON property coming in that can map to more than one focal, property. Right now, I mean, in the implementation, it's just not defined because, like whatever reflection order, you happen to find whatever property first. I don't know if I should special case that to be an exception case as well, to say, hey, you have, POCO class. I don't know what property to assign this value to. Are we just is undefined okay?
If the developer makes two different POCO properties with the same name, effectively, just with different case?
Yeah, so I have a property called foo in uppercase and a property called foo in lowercase, and then my JSON has foo in a mixed case, say, for example, and I turn on case insensitive. Which one do I set?
Well, I would think that as you're in the deserializer, like I would imagine that you're building up the list of properties to be bound before you start deserializing. I would imagine that at that point you could probably just detect and fail that, hey, something's ambiguous here, I don't know what to do. Right?
Yeah, we do lock that property down in the sense you can't change it, once serialization has started.
Yeah.
I'm just, like I said, it's just a question. Do we want to try to detect that and throw some exception, or not worry about it?
I wouldn't, like, I wouldn't detect that on deserialization. I would probably detect that on instantiating the deserializer itself, to be honest. Like before you even have a chance to pass a payload to it.
Yeah, normally then on the first time you deserialize is the time that we would build up that cache.
Oh, okay. Okay, sure.
So it's at the same time. But yeah. I mean, but yeah, you're right that it could be done once ahead of time, during the warm-up phase, and not, have to do something every single time.
Yeah. Okay.
Okay.
So I had a question on design.
I'll say you request, but okay, before and also that would have to apply to camel casing as well. And so I would have to loop through every single property, vertical policy on it, and see if there's a duplicate, which is kind of slow.
It's actually not that bad because it's only done once, and the way that you can do it is literally just new up a hash set using whatever comparer is appropriate and throw all the names in there and see if there's a match. But it's work you do once, and it's pretty fast.
So what happens if somebody sets the property name using JSON name attribute that matches another property name?
I mean, that would be what you do, right? Like you would, when you're looking at all of the properties that are eligible for binding on the type, you would run all of the property names through the appropriate JSON name policy, get what the converted name is, and then take all of those and throw those into a hash set and see if there's any collision there. And that hash set would use either an ordinal comparer if case insensitive is false, or an ordinal ignore case comparer if case insensitive is true. And if there's a match, then you say, like, I don't know what you're asking me to do.
And this would happen both for serialization and deserialization?
It would only happen for deserialization, I imagine. Like, serialization, okay. I'm not too worried about.
Okay.
I mean, if you wanted to guard it for deserialization, or for serialization, you could. It's just, I guess I don't care all that much. I mainly care about data coming in, not data going out.
Okay, so I mean, the feedback I'm getting is yeah, we should verify all attributes and all properties on the POCO against camel or whatever policy you might have.
Yeah.
And then case insensitive, and then thorough.
Yeah. Yep.
Does everybody agree with that? I mean, or not agree, or have some opinion? Even though we say it's cached, there still is a cost associated with it, especially if people misuse the options class.
Oh, yeah.
But yeah, it is cached, and only done once for a given type. Okay, I have nothing else then. I'll make the changes, some of the naming changes in the protected constructor we talked about, and add some validation logic to the design.
Awesome.
All right, I posted the notes and I updated the labels. Alrighty, then let's close this one here. Let's talk about this one here. And then this one here.
Is this a 60 or 120 minute?
It's a 61, so we have 40 minutes left because I lost the room.
Okay.
Sadly. Anything else you want to talk about? All right, then let's go with this one here. So,
It's just adding async methods then?
oops.
I guess we just closed that.
I think that's the intent, yes. Yeah, basically they're proposing a bunch of new methods, right? None of them exist today.
Begin transaction async. Oh, right, okay.
Yeah, it's not. It's unfortunate that begin is used in the async model as well as in that.
No, I get it though.
But, yeah.
Because beginning a transaction is itself a network round trip.
Yeah. And the API already exists today. And the non-synchronous version, so it's just.
Do you know what the difference between close async and dispose async is?
So in ADO.NET, on a connection, you can close it and open it and closing it and open it.
I
You
see.
can only dispose it once.
Got it. That makes sense. It's ironic that you can cancel.
Yeah.
That feels weird to me. What does that mean?
I would assume that terminates the IO request.
So when you run a command, right, the command might be, delete the entire database, right? And halfway through you say cancel. So then basically it rolls back the transaction.
I see.
You could also say, like, if it takes too long to send this cancellation request, then don't hang around waiting for that to go through. Just move on to the next thing.
I guess what I'm wondering is what generally triggers a call to cancel async? If it's a cancellation token, is it the same cancellation token that's being passed in? Because then that would be a no-op, kind of.
You're saying if I call begin transaction and then I don't know, call whatever the thing is called, execute async on db command, and then later on just cancel the cancellation token, how is that different from calling a cancel async?
Yeah, I guess I'm asking two things. One is exactly what you just said, and the other is who is generally responsible for calling cancel async? My intuition, and this could be entirely wrong since I haven't used db command in like 10 years, is generally with a cancel method, you would do something like cancellation token.register, and the delegate you pass calls something like cancel. Right, so that when the cancellation token is triggered, it calls cancel. But in this case, if you did that, presumably you'd be passing in that cancellation token, and by definition would have already been canceled when this was called. So I guess I'm just wondering what does a typical usage pattern for cancel async look like? And to your point, if it's actually just canceling something on operations you previously started, they all take cancellation tokens. So, but I may just not understand its usage.
The only places I see internally that do it are on cancellation token.register.
Yeah, like this might be something.
The ones who call the current cancel.
Might need to pull them into explain these. Because the only thing I'm just trying to imagine scenarios where you would want to pass in a cancellation token, which is like if the network operation's taking too long, you want to be able to cancel the cancel operation. But if you cared enough to even send a cancel command, you probably wanted it to finish.
Yeah.
Without interrupting it.
Right, which is generally the same logic that we use to say dispose async doesn't take a cancellation token, because dispose is about tearing down your resources. It's often happening when you've already canceled something. You cancel something and then you call dispose to clean up in a finally block.
Yeah.
And so I'm wondering if cancel async is a similar thing.
Is value task the correct return type for dispose async?
Yeah, dispose async is special. So the reason we chose value task is while most implementations will probably just end up returning a value task that wraps a task, or that's just default because it's already complete synchronously, there are going to be a fair number where it actually can be sort of the more sophisticated implementation that reuses an existing object.
Okay.
And in particular, all of the async iterators the compiler generates do that. The same object that's used for the enumerator, that's used for the enumerable, is used for the enumerator, is used for every value task returned from move next async, and is also used as the backing for dispose async's result.
No, I get it. I really wanted to make sure that wasn't a typo here. But, okay.
No, that's correct.
Okay,
The IAsyncDisposable interface says that dispose async returns a value task.
Is when people are implementing async disposables, do you generally recommend that they expose a public disposed async method as done here, or that it is an explicit interface implementation?
That's a good question. We haven't really discussed it much.
Okay, because these are all virtual, which means if you really wanted to override them, like, you should make them public virtual. Right?
Yeah, I mean, given that it's virtual, I think it makes sense for it to be public. If it wasn't virtual, I'm still not sure there's any good reason to hide it.
Okay. Okay.
We don't have the dispose pattern effectively then for async?
No, because the dispose pattern is entirely predicated on dispose being called from either dispose that takes a bool being called from either the public dispose or the finalizer, and you don't call this from the finalizer, so there's only one.
So what does it mean if you're async disposable and synchronous disposable? That basically means that the synchronous dispose.
It's up to the caller to decide which to use.
Jeremy?
And functionally they should be equivalent.
Yeah. Just
one doing sync IO and one doing async IO.
Yeah.
Jeremy, can we kill the dispose pattern in the new framework design guidelines? Because no one should be writing finalizable objects anymore. Sorry, go ahead.
No, because we don't make we don't change rules unless they're broken, and that rule is just outdated. But there are still times that you want to add a finalizer, so it still makes sense.
The problem that I see
and we
is,
don't generally hide dispose as making it an explicit cast, because a lot of people find out if something's disposable by using IntelliSense and typing .d. So hiding should be done only when needed.
Yeah. Okay.
But for the synchronous dispose, we'll keep the pattern the way it is, and we'll say async dispose doesn't need it because there's no finalizer.
So
all of these objects already implement IDisposable, right?
Correct.
Okay.
The other question I have for you, Steve, is like the close async also returns value task. Do you have thoughts on that? So everything else does task. Except for, of course, dispose async.
Yeah, I know Shai thought through these and was sort of taking into account my guidance that unless it was perf critical, it should return task, and perf critical on the async completion path in particular. I don't know why. I'm having trouble understanding why close async would be value task. It'd be worth asking him. Maybe there's some scenario. I'm not sure what the scenario would be.
They might have dispose async call close async, and it might just be for convenience.
Well, dispose async could call close async. That would be fine because you can wrap a value task around a task. You couldn't do the opposite. You couldn't have. Well, you could. I mean, close async could await dispose async. It would be an async implementation.
Yeah, it's just if I were designing this, like if I had a dispose method calling a close method, I would probably just, for ease of understandability, just propagate the return type because it wouldn't occur to me. Yeah, it just wouldn't occur to me that one's implicitly convertible to the other.
Right. Yeah, I think my two questions are basically around close async's return type and cancel async in general.
Yeah. I recorded both of them. I will ask them that. And then I think we should.
What do you think about the comment at the end?
Yeah, that was the other question that I just thought about. Like, it seems a bit weird to add a method just for consistency reasons, but
mean, I guess there was a lot more discussion there that we missed.
Well, I just
Can you scroll down? It looks like there may be an explanation for close. Or, yeah. Yeah. And it seems like maybe it should just be return task, but it doesn't. I don't know. Whatever's fine.
Yeah, you're not calling this in a hot loop.
Yeah.
I mean, if you do, you have other performance. But...
Yeah.
Does
close return a connection to the connection pool, or does it actually close a connection and just like, get rid of it?
I don't remember. I thought that at least SQL does pooling.
Is this db connection.close?
Yeah, I believe so. Well, but the problem is that's an abstraction, right? You would have to go to the actual provider.
Yeah, I'm looking through it.
I think pooling is not done in the framework. I think it's provider specific.
Oh, never mind. Okay.
Like at some point, I'm pretty sure SQL did connection pooling already under the covers, but
That's what I'm looking for.
Why do you ask, Steven?
I was trying to understand how expensive close actually is. Like, if close implies you have to open a brand new connection and do all those round trips, then it's definitely expensive. You know, and because it's not just the close call that matters; it's what you do to get another connection. But if close async is just putting the connection into a collection, and then the next time you go to say open, it just grabs it from the collection, then in theory, I could imagine maybe there's a tight loop where you're calling open, close, and it's just reusing the same connection over and over and over and over.
Yeah,
Right.
it looks like they actually do have some kind of pooling mechanism for SQL connection. I mean, I'm just skimming the code, but I see references to a connection pool. And that connection pool is at least touched from within the dispose method. Or from within the close method, sorry.
All right, I think we're about to leave the room, so let me just write the last thing up. All right. Let me bounce this back. Do API needs work. And then they can come back to us. All right. Let me end the stream then. And then if anything urgent comes up this week, I can set up a one-off. I was hoping for 2 hours, but apparently the room got lost.
Yeah.
Sorry for that.